Hmm. Yeah, I've started sharing. Thanks. Okay, so hello, I am Kwanit Gongopadhyay, and today we will be. I'm okay. So first, let me introduce myself. I'm Kwanit. I'm one of the founding members of Max Club, and I was a part of Max Club till last year, but now I am not. So all the rumors you have heard that I am the president, please forget them. I am not the president. I am not a member. I am not a part of Max Club anymore. Okay, so let us start the lecture. Today I will be teaching you a very standard and famous, popular proof technique, useful also, which is called mathematical induction. I think many of you already know it. It is also taught in school, so class 11, 12 people I think already know it. But still, like we will do some non-trivial examples which might be enlightening, and then we will obviously have that ask me anything section. Okay. So what is induction? Can any of you tell me?
Induction is a method of proving.
Yeah, very good. So induction is a proof technique, I can write. Can you name some other types of proof techniques apart from induction? Oh, I sent you the link only. You people know everything. Okay. If you have read that wiki article, you know everything. Anyways, so those who have not read, you can prove obviously by mathematical induction, as one of you said. How else can you prove something? Remember the proof of root
And
2 is
also proof by
irrational?
contradiction.
Yeah, very good. So that is proof by contradiction. You all know the proof, na? So I planned I would do it today, but I won't if you all know. Proof by contradiction. Root 2 is irrational. That proof is by contradiction. Everyone knows that proof, right? I think it was done in one of the lectures by Sabyasachi, I think. I don't know. Okay, so another proof which you most commonly use, still you don't know the name, is direct proof. What is direct proof? Direct proof is proof that a plus b whole square equal to a square plus 2ab plus b square. What do? You directly multiply, proof done. A plus b whole square, a plus b into a plus b equal to a square plus 2ab plus b square. LHS, RHS matching, done proof of that. So this is a direct proof. Okay. Now if I ask you to prove root 2 is irrational directly, how will you prove it? Like, you can't think of anything, right? Like, that's why.
By contradiction.
Yeah, so like when a direct proof seems a bit tricky or not possible, you can't think of a direct proof. Like first of all, we always try a direct proof. Like this is not a strategy. You naturally try it. That's what comes to us naturally, na. When you see a question, what do? You try to directly do the question. You don't try to assume that suppose the question is false or something. That only happens if you can't approach it directly. Then you think of other ways of proving. So if direct proof is failing, then I will try proof by contradiction. Root 2 is irrational, that proof. Assume root 2 is rational, then follow a series of steps. You know all that. You know that proof. So I am not repeating. Everyone knows, na. Just confirm, please. If anyone does not know, please tell me. Hello. Hello.
Yeah.
Yes, no.
Everyone knows the proof that root 2 is irrational by contradiction, right? Then that proof also where Euclid proved there are infinite primes. I saw all that in the PPT. It was in the PPT of the lecture only. You
Yes, Dada, we
attended
more or
that
less have an
lecture.
idea about these.
Oh, okay. Okay, so proof by contradiction also I think you know. So now let us move to the main topic of today's class, which is proof by mathematical induction. So basically, mathematical induction is like dominoes. Okay, so first let me do one proof, then you will understand better. So we have this formula. Have you seen this formula? Anyone who has not seen, please tell me.
Yes.
Okay, so I will prove this using induction. How? So first what we do, check the formula for n equal to 1. Let's see what happens. LHS is, what is the LHS? Someone tell me. For n equal to 1, what will be the LHS?
Sir, one only.
Yeah, 1 only. And RHS, according to the formula, 1 into 1 plus 1 by 2. These two cancels. Again, it will be 1 only. So LHS equal to RHS. So n equal to 1 case, I know it is 2. I don't know whether the formula is 2 always, but I know that the formula is 2 when I put n equal to 1. Okay. Now let us assume that for some number k, which is a natural number, 1 plus 2 plus 2k equal to k into k plus 1 by 2. This we are assuming. Okay. That suppose this is true for some number k, it can be 5, it can be 50, it can be anything, like some k. Okay, so now what happens? Now what is the next term? The next term is this plus k plus 1, right?
Yes, sir.
This will be my next term. अरे मैं सर नहीं हूँ रे. This is the LHS. And what is the RHS? RHS is also same thing. We will only add a k plus 1. So k by 2 into k plus 1 plus another k plus 1. We added a k plus 1 on both sides basically. So everyone understood this step now? Anyone having trouble, please tell me. Okay, I'm assuming everyone understood. So how much is this? I can take k plus 1 common, k by 2 plus 1. This becomes k plus 1 into k plus 2 by 2. Now see the original formula. In this original formula, hmm, if I instead of n, I put k plus 1. Okay. So what will be the LHS? The LHS for k plus 1 will be this thing, na? Right?
Yes.
And the RHS for n equal to k plus 1, it will be this thing, right?
Yes.
It is n into n plus 1 by 2. So n equal to our k plus 1. So k plus 1 into k plus 1 by 2. So it is basically this thing only. So what did we prove? We proved that if it is true for k, it must be true for k plus 1, right? We proved this statement
Yes.
basically till now. We have not proved the formula, we have just proved this one.
Is there
Okay.
something called forward backward induction?
I have not heard of it, but
I just heard.
I will.
I'm not sure of that.
Acha. It may be. Like, I don't know. I don't know everything. Na. I know only how much I know. If you have read about it, then very.
Can you please
I
scroll
will.
up?
Can I please?
Scroll up
Okay. How much?
a little bit up. Okay, okay, I've seen it.
Okay.
Thank you.
Hmm. So, uh, denote what is our statement? Statement is 1 plus 2 plus till n equal to n into n plus 1 by 2. Okay. So this statement is for n. So I denote this statement by Pn. Okay. So what is my Pn? Pn basically says that this thing should happen. Okay. Just a notation, nothing to think about. So P1 is true, right? We proved, we checked. LHS was equal to RHS, both were just 1. P1 is basically the statement for n equal to 1. Everyone understood why P1 is true?
Yes.
Okay. And if Pk is true, then Pk plus 1 is also true, right?
Yes.
So if I put k equal to 1, what do I get? P1 is true, I know that. P1 is true, I know that. Now if I put k equal to 1, if Pk is true, then Pk plus 1 is true. So if P1 is true, then P2 must be true. है ना? Everyone understood this?
Can you go one?
Why P2? So we proved this, na? This much you understood? If Pk is true, then Pk plus 1 is true. Right?
Yeah.
Yes.
So if I put k equal to 1, what will happen? If P1 is true, then P2 is also true. Right? Basically, if my first, if it is true for n equal to 1, then it is also true for n equal to 2. If you don't want the P notation. Is the P notation a bit confusing for you all? Okay. So, acha, now if I put k equal to 2 now, so if P2 is true, then P3 is true, right? Now if I put k equal to 3, so P3 is true, that will imply P4 is true. Are you seeing what is happening? We can go on forever.
Yes, sir.
We
So
can go.
every number is being true. Everything is being true.
Yeah. Basically, it is always true. For like, if k is an integer, natural number, then it is always true. I don't know about 2.5 or something. This formula is like does not even make sense. I think you are adding integers, so it must be a formula for integers only, positive integers only. Everyone understood what happened till now? If anyone did not understand, please tell me now, because I will be using this a lot. today. Okay, so everyone understood, I think. Okay. So basically it is like dominoes. All the dominoes are there. Okay, so this is say P1, this is P2. All these are dominoes. You know dominoes, na?
No, sir, I don't know what I got.
Arey, you don't know dominoes. Okay, wait, let me
Domino's pizza, you know.
Not Domino's Pizza. Domino.
Arey, this thing.
that one that if we kick one, other all the fell
हाँ
back like that.
सी ना सी हाँ देखो आराम से देखो अभी dominoes. You are seeing now what is happening. If the one falls, then the next one also falls. Right. Every tile is kicking the next one. Are you seeing what is happening?
Yes, sir.
Okay, very good. ये हो गया चलो. हाँ, so this is like dominoes. Consider an infinite tile of dominoes. Okay. So what is a property of dominoes? That given any two dominoes, if I push one, then it will make the next one also fall. Right? And this is falling, so it will make the next one also fall. This is falling, this will make the next one also fall, and so on. Like suppose all the dominoes are tiled like this. Okay, infinite dominoes. You just come and push one. So this one falls, this one falls, this one falls, everyone falls. Right? Okay.
Yes.
Please interact. Okay, okay. It is online class. I can't see your face. Please say yes, no something, or else I won't understand. Okay. So how is it like dominoes? Like you have to check a base case. Base case is the lowest case. Here it was n equal to 1. We checked n equal to 1. Check the formula for n equal to 1. This was the base case. This is my first domino. Okay. Now we have to check if this is true. Okay. So if it is true for some number, then it must be true for the next number. If this statement you can prove anyhow, and then you check one base case, then everyone will be true. It will always be true. Right? Did you understand? Okay, let me write step 1, base case check. Step 2, try to prove if it is true for k, that implies it is true for k plus 1. Okay. Now this, if this you can prove somehow, and you have a base case checked, then basically you have proved the thing by mathematical induction. Okay. Everyone understood, na? Everyone understood.
Yes, sir. Yes.
everyone. किसी को कोई डाउट नहीं है. Okay. Okay, so I'm moving on. Okay, so basically induction is of two types. One is called strong, one is called weak. Okay. So the type of induction which we did just now, it is the weak type. Okay. So what is the weak type? Let us see. Weak induction. Weak induction. In weak induction, step one is check the base case. Step two, assume pk is true. Prove for pk plus 1. So this is what we just did. Now what is strong induction? Strong induction is just a little bit different. Step 1 is the same. Check the base case. Step 2, assume. Acha, suppose the base case was P1. Okay, it might not be, but just let us assume for now. So assume P1, P2, everyone till Pk is true. Okay. In weak induction, we just assume that it is true for K. In strong induction, we are assuming that it is true for all numbers from 1 to K. Then prove Pk plus 1. Okay. So even if you can prove by assuming not just the previous term but all of the previous terms, still we can prove it by induction. Understood? Uh, Example will make it better. So everyone understood now how induction works.
Yes.
Okay. So now, when is induction helpful? Like when is proof by contradiction helpful? When you can't prove it directly and you need to like find some other means to prove it. You can't think of any direct method. So you can try proof by contradiction. So when is induction useful? Can anyone tell me? What did you observe? Like, what do you think? Which type of statements can be proved using induction? Like, you need some. I could not hear you. Please repeat.
Writing some simple statements.
Yeah. So, induction is very useful in the most complex of situations. Okay. Like, in school, it is taught very badly. That's why you think it is very simple thing, very pathy and trivial questions can only be proved using induction, but it is not like that. You can prove a variety of things and like a huge variety of things. Okay. So no, but like when is it useful? When you have to prove a statement for positive integers. You can also do it by for negative if you just replace it with a minus sign. Like basically you have to prove it. You can't prove it for all integers. You need a starting point. Like it cannot be infinite both ways. You have to start somewhere. So the starting point, it can be 0, it can be 1, it can be 2, it can be 50. Like there can be a statement which is not true for the first 49 numbers, then from 50 it is true, but it is true after that forever. So there the base case will be for n equal to 50, and after that you have to apply the induction. So always think of each number as a domino. Which domino you have to push, that is the best case. So it can, like, it will not always be the first statement which is true. It can be the seventh statement which is the base case for n equal to 1 to 6. It may be false also. You have to think a bit. Like, it is not always very simple, as someone said. It is not so simple. Okay. So when you have a statement for integers, positive integers like that, but like, just by seeing the question, you can think of applying induction if there is some n, or there is a sequence of integers or something like that, a formula, something like that. But induction is also very useful in questions where you least expect them to be useful. For example, suppose there is a question, okay, and in that question you have to prove something and there is no formula, no statement, nothing like that. But the thing you have to prove can be proved using a formula, and that formula you have guessed. You don't have a proper explanation of why it is true. You have seen a pattern and you have guessed that I think this formula should work in this question. Okay, so if you need to show that, if you need to prove that question, so you need to prove that your formula is true. So for that you might need induction. Like, this is an indirect way of how you might use induction. It is not always directly that you have to prove something for n and I will directly apply induction, not like that. There is a question and you think of some possible pattern and formula and see, and like, you all know the word conjecture.
Yes, sir.
Anyone who does not know about conjectures, please tell me. Okay, so conjecture, it is like a theorem, but it has no proof. Okay, so like, you know Fermat's last theorem? Anyone knows? Very famous theorem it is. It says that a to the power n plus b to the power n equal to c to the power n has no solutions for n greater than 2. A, B, C are integers. Simple statement. Okay. Basically, you know the Pythagoras theorem, na? 5 square plus 12 square
Yes,
equal
sir.
to 13 square. This is a Pythagorean triplet. So what this format guy is saying is that you will not find any triplet like this of integers where a cube plus b cube equal to c cube. You will not find. You will not find a to the power 4 plus b to the power 4 equal to c to the power. You will never find something like this. Or a to the power 1729 plus b to the power 1729 equal to c to the power 1729. Basically, Pythagoras theorem is true. You will find Pythagorean triplets, but you will never find uh, for cubic, for biquadratic, or for any higher power. This is the statement. Basically, he tried to find and he could not find, and he thought that I will never be able to find. So that is a conjecture. Okay. So format conjecture. Format lived in 1600s or something. Okay. So when he said this statement, it was a conjecture. And in 1990s, it was proved by a British mathematician, Andrew Wiles. Okay. So for all these years, it remained a conjecture because it did not have a proof. You are guessing something is true, but you cannot prove it. Okay. Are you understanding, everyone?
Sir, I joined just now, sir. Could you please tell me, sir? Could you please scroll the page a bit?
I advise you to watch the recording. I can't repeat so much.
Okay, sir.
So can you
Like
prove
we did a lot of
Fermat's
things.
conjecture?
The proof is more than 100 pages and I can't. Like I think only 10
100
20
pages.
people on the world. 100 pages long proof it is. And it took 300 years to prove, and hardly 10
Sir,
20
is all
people
the proof, I
understand
mean
the proof.
mathematical statement, or we are taking for numbers only?
Mathematical statements for natural numbers is where we use induction.
No, sir, I mean that
I
we are
was talking
taking
about
one by
conjecture.
one. I mean, for 100 pages, we are taking one by one, or we give some solid statements also.
What one by one?
No, I was saying that if it is 100 pages, then we prove one by one.
Like there is only one theorem which you have to prove, but for that proof only you have to prove many other things, and like slowly it will build up. Okay, do one thing. There is this book called Fermat's Last Theorem by Simon Singh. Okay, it does not have the proof. Don't worry, I'm not scaring you. It is a pop sci book. You can read this book, very nice book. You will understand.
What will we understand?
Okay, like how 100-page long proof developed, and like what was the journey of this theorem
So
through
basically, other
300
than the
years.
proof,
How
we will get everything in the background.
it is like a historic account. It is not mathematical. It is like light reading. Kusagra is saying 100 long proof. We can't solve POTW. It took 300 years. Don't worry. POTW is 1 week stuff. Okay. So what I was saying is, when is induction useful? Suppose you have a question, and to solve that question you see a pattern and you come up with a conjecture that I think this formula should be true, but I don't know why it should be true. I am just guessing.
It can be
Okay.
used when you have an intuition.
Yeah, like you have a feeling that after seeing a pattern you think this must be true. अरे यही तो होना चाहिए. So in those cases also you can use induction to prove your claim, and then use that conjecture to prove the question. Okay. So don't think that induction is very simple, and induction only happens in that questions where there will be a n, there will be a sequence, there will be a formula, something like that. Induction can happen in combinatorics also, number theory also, algebra also, everywhere. I don't think geometry has examples, but apart from geometry, like it can appear anywhere in disguise. So always keep your eyes and ears open. Don't forget induction, however basic it may seem. Okay, so let us solve some questions. You people will uh, tell me the next steps so that I can wait. Let me open the handout. So this question, for every natural number n, prove that n to the power 7 by 7 plus n to the power 5 by 5 plus 2n cube by 3 minus n by 105 is an integer. Okay, this is the question. Now someone tell me how you will prove it. What have you learned till now? How will you prove it? Hint is induction only. You will prove it by induction only. Just tell me the steps. Please tell me anyone.
At first we just add them up, like we add fractions.
First, we can use the base case with 1.
You can add them up, but like
I mean, then we can
Very
prove that the numerator is divisible by 105 by induction.
yeah, you can do that. You can do
We
that.
can use format
but
Newton
like-
theorem also
The
here.
first thing to notice here is that 105 is the LCM of 7, 5, and 3, and that's the main hint.
Okay. All of you are using nice number theory things. But suppose I'm a class 5 guy, I don't know any divisibility, anything. Okay, anyways, as we are learning induction, we will prove by induction. Like, I'm not saying your proofs are wrong, all of you can do that also, and I encourage you to complete the proofs, write down the proofs. But just because today's class is about induction, we will do it about induction, no other reason. Don't get disheartened. Okay, so step 1, someone tell me step 1.
We have to take n equal to 1.
Yeah, we have to take n equal to 1. Why n equal to 1? Why 1 is the minimum? Because for every natural number. So what is the minimum natural number? 1.
Yes.
So what is this for n equal to 1? 1 by 7 plus 1 by 5 plus 2 by 3
2 by 3
minus
minus 1 by
Hmm.
155.
Someone calculate this. I don't want to.
Sir, 1.
This is 1.
Okay, okay, very good. Thank you. Hey, इसको XP point दे दो यार. What is step 2?
Sir, n is equal to 2.
So take the LCM.
That is the number theory thing. Na? Okay, so another reason why induction is useful. Some of you came up with this beautiful observation that 105 is the LCM of the other 3 denominators. Okay. Or you can also just add all the fractions and then the numerator you can check division.
Simply we prove using a
That also
format
you
Newton
can do.
theorem.
But I think there are many people who did not think of these ideas also, right? Only 2-3 people thought of this brilliant ideas. The other people did not think of it. So if you know induction, you have this extra power in your hand that even if I don't know how to prove it directly, I have another alternative, another backup plan. Like if you can prove it directly, well and good. But if you cannot, then also you have a backup. So it is always very helpful to know induction. That is the moral of the story. So step 2 is assume it is true for K. Assume Pk is true. What is Pk? K to the power 7 by 7 plus K to the power 5 by 5 plus 2K to the power 3 by 3 minus K by 105 is some D, where D is an integer. Assume this. Okay. Now try to prove Pk plus 1. Okay. So what is Pk plus 1? What is the LHS? K plus 1 to the power 7 by 7 plus K plus 1 to the power 5 by 5 plus 2 into K plus 1 cube by 3 minus K plus 1 by 105. Okay. Someone please expand this.
Sir, we have to expand this to prove.
Dada,
Not fully, I
Theorem.
think. Huh?
binomial theorem hasn't been done yet.
Acha.
You
Oh,
can
binomial
simply
theorem I will do today so. Acha, okay. So you can
Anyway, I'm
complete the
telling the
proof
expression.
after.
It's K7 plus 7 K6 plus 21 K5 plus 35 K4 plus 35 K cube plus 21 K square plus 7 K plus 1 for the first one. 4 to the power 5 it's K to the power 5 plus 5 K to the power
Okay,
4
okay, stop.
plus 10 K
Okay.
plus 10
Slow.
K.
Wait. Okay, so the thing is, to know how to expand this, you need to know binomial theorem, and that I will teach in today's class. Okay, so exercise, complete the proof after class.
this is first homework.
Yeah, this is first homework. Very good. Thanks for pointing. Okay, so another question. You know about the Fibonacci sequence, na? Fibonacci sequence is f1 equal to 0, f2 equal to 1, and fn equal to sum of the previous two terms for n greater than, just greater than.
Sir, that's greater than equal to 2. I mean,
Greater than 2, not equal to 2.
yes, sir. So it's greater than.
Okay. So now prove that you know what is relatively prime or co-prime.
Sir, what is?
Relatively prime or co-prime.
Sir, I don't know the first one.
Same
both
thing.
are
They are
same.
the same thing, just two different names. Two different names of the same
Sir,
thing.
both great common divisor as 1.
So basically HCF is 1, है ना? So prove that HCF of Fn minus 1 equal to 1 for all n. अच्छा ये n plus 1 बस. Okay. This is the question. How will you prove it? Anyone? Any ideas? Please tell me. Anyone? Any ideas?
Just wait a minute.
Okay. Oh, you all are trying. Okay, try. Okay, I
I mean,
give
we
you 2
can
minutes
proceed by
to try.
induction.
Say. That is obvious. Like what is
Yes,
the step 1? Step 1 is check base case. What do you do after that?
yes. GCD of fn minus 2 comma fn minus 1 is is 1. It is by induction hypothesis. So from here, if we assume that fn comma fn minus 1 is d, suppose, so it will automatically turn out that d should be 1. Otherwise, it will contradict the induction hypothesis.
Yeah. So how will it turn out? That steps you have to show just us. I think you know already the steps. That only I will write down. Okay, so you are right. What is HCF of 0 and 1? 1 only, na?
1.
Okay. Step 2. Assume 2 for K. Okay. So suppose HCF of Fk and Fk plus 1 equal to 1. Okay.
Okay, sir.
And now assume that HCF of Fk plus 1, Fk plus 2 equal to some D. So I can write Fk plus 1 equal to dA, Fk plus 2 equal to dB, where HCF of A and B is how much? Think about it.
Sir, 1.
Sir, 1.
Very good. Why is it
1.
1? Why is it 1?
Sir,
Someone
because
tell me.
HCF of Fk plus 1, it is dA. So, sir, dA, comma dB. So, sir, then dA, comma dB, then it
A
will
and
become
B's
D into
HCF is not
HCF
1,
of
then
A,
we will
comma
have a
B,
common
sir.
factor.
Yeah, if A and B have a common factor, then that is also a part of the HCF. So they cannot have a common factor. Right. Everyone understood why HCF of A and B is 1? Acha, if anyone did not understand, please tell me. There is nothing to be shy about. Okay, I'm assuming every. Huh.
Because
This,
D is the common multiple.
like if A and B had a common thing, then that into D would be the HCF, right? HCF is the highest common factor, so there cannot be any higher term. Okay. Now Fk plus 2 equal to Fk plus 1 plus Fk, right? So dB equal to Fk plus 2 is dB. dB equal to Fk plus 1 is dA plus Fk. Okay. So D into B minus A equal to Fk. Right. Now what did we assume? HCF of Fk and Fk plus 1, which is dA, equal to 1. Okay. If HCF of Fk and dA is 1, and from here we know that D divides Fk, right? Right.
Yes, sir.
So from here, can you see why D equal to 1? Like if D was greater than 1, then HCF would have been also greater than 1.
I
Sir.
don't understand.
Huh?
I'll repeat once.
Yeah.
Sir, can you please
So-
explain how did you say that if B divides Fk, then D is 1?
Okay. So if D divides Fk, then Fk is again some D into C, na?
Yes.
Right? So if Fk is some D into C, then what is this HCF? This HCF is nothing but HCF of DC and DB, not DB, DA. So this is D into, wait, let me write it in next line, is equal to HCF of C and A into D, right?
Yes.
But this entire thing is one that we have assumed in our induction hypothesis only, right?
Yes, sir.
So this is also one, this is also one, because they are integers. They are positive integers, so both must be 1 into 1 equal to 1 only. This is the only possibility.
Sir, can I tell
Hence,
another
D
thing?
is all. Yeah, yeah, go on.
Sir, here, sir, from that HCF of Fk comma dA is equal to 1. So, sir, we got D, Fk is equal to D into B minus A. So, sir, it will become HCF of D into B minus A comma dA is equal to 1. So, sir, which is equal?
Basically, B minus A is only sigma.
Yes, sir. Sir, actually, what I did was, then I got D into HCF of B minus A is equal, B minus A comma A is equal to 1. So, sir, we know that HCF of A comma B is equal to HCF of A comma A plus B, A plus KB or B plus KA, where K is an integer.
Yeah.
So, sir,
Yes,
with
you're
that.
right. Very good, very good. Yeah, okay. Yeah, that thing I will teach in the next class, so I'm not using that right now, but you are right.
Thank you, sir.
You can try any other method also, but since we are learning induction today, we will stick to induction. So what did we just prove? We proved that uh, truth for k implies truth for k plus 1. And base case we have checked only. HCF of F1, F2 is already 1. And we have proved this thing also. Hence proof. Yes.
What was the C
Okay.
in the proof part?
What?
What was the C? Where did you get the C? It was D into A minus B, right?
What? C equal to B minus A. Like if you don't need C actually. You can write D into B minus A and D into A. C was just like to uh, write it in a smaller way. Take less space basically because I don't have much space.
Can you please scroll up so that we can copy?
Mhm. Where? Say from step 2. Step 1 so you know only. Have you copied? If you have copied, tell
Wait,
me.
wait, wait, sir. Last.
Okay, okay. tell me if you need to scroll up, down. Done.
Yes. Yes.
Okay. Okay, so now we will do a very important theorem using induction, which is a very important tool. Okay, so first let me just introduce some notations. You all know factorial?
Yes, sir.
Yes, sir.
Okay. So this thing, this is known as n choose r. It is given by this thing. It has a combinatorial interpretation also, which you will learn when you learn combinatorics in Maths Club only. But for now, we don't need to think about the combinatorics part. We just need this formula. Okay. Yeah. So the thing with induction is that is the thing with induction. You don't need much intuition in anything. You just need a formula and prove it. But it's the formula that just like in that 105 375 that example also. These people came up with the LCM trick. But even if you did not come up with the LCM trick, you can still prove it by induction. That is the power of induction. So again, binomial theorem you can prove by combinatorics also. But even if you don't know anything about permutations, combinations, counting, you don't know anything at all, still you can prove it using induction.
So what is written
That is why you
at
must
the first?
what?
So what is
This
written?
acha, this is
NR.
there is a bracket, long bracket, upar n, niche r. It is read as n choose r or NCR.
So what does it mean?
That only I said na, the meaning will learn in combinatorics. Now if I sit to explain the meaning, it will take again 10 minutes and you will learn it when you learn combinatorics. For now, just know
It
the
is
formula.
basically taking n things from, I mean, a set of r things without considering the order.
No, the reverse. Taking R things from N things.
Oh, sorry.
Oh. So I am just introducing a notation. Don't need to think anything about how it came, what does it mean, anything. This is just a notation. Okay, so what is the binomial theorem? The theorem is x plus a whole to the power n. Acha, everyone knows summation notation. This sigma.
Yes, sir. We know.
Anyone who does not know, please tell me.
Sir,
Okay, everyone knows.
I'm not sure.
Acha, acha. Okay, leave. Let's not leave. So the expression is given by nc0 x to the power 0 a to the power n minus 0 plus nc1 x to the power 1 a to the power n minus 1 plus nc2 into x to the power 2 a to the power n minus 2 and so on. This is the summation. This will go on till n minus 1 x to the power n minus 1 a to the power 1 plus n x to the power n a to the power 0. This entire expression, you can understand the summation, na?
Yes.
This is basically just a formula. There is nothing to understand if you don't think about it combinatorially. But basically, the theorem is if you want to expand something like this, you can expand it like this. Bus. That is the
You can show
theorem.
them the Pascal triangle to find out fast.
You can use the Pascal triangle. Acha, why the Pascal triangle works? That for that you have to know that identity na. NCR plus NCR plus 1 equal to n
Sir, n
plus
plus
1
1
CR.
CR plus.
No, CR only. No?
It's R plus
Okay,
1.
sir.
It's R plus 1. Okay, wait, let me see. N factorial by R factorial n minus R factorial plus n factorial by R plus 1 factorial n minus R minus 1 factorial. This thing equal to n factorial by R factorial n minus R minus 1 factorial. If I take common, I will get 1 by n plus 1 by R plus 1. This is what I will get, na? Please check my calculations.
First term will be n minus r.
Yes, sir. N minus R.
N minus R. Right. Thank you. So this will be R factorial n minus R minus 1 factorial n minus R plus R minus 1 R cancel. Wait.
Sir, it was R
No,
plus
plus
1.
1. N minus R into R plus 1. So if you expand the bracket, what you will get? N plus 1 factorial divided by R plus, you are right, n minus R factorial. So this will be R plus 1, right? Okay. So keep this identity in mind. We will use this for proving the binomial theorem. I'm just making a box around it. Just note down this identity.
I couldn't understand the proof.
A proof is just algebra. Just take things common and add fractions. But there's nothing in there.
Can you scroll up?
Wait, you just need to know this thing. N factorial is how much? N into n minus 1 into and so on till 1, right? So if I take n common, I can write this as n minus 1 factorial, right?
Yes.
Okay, so this formula if I use, so from these two expressions, I have taken n factorial common in the numerator, r factorial common in the denominator, and n minus r minus 1 factorial common in the denominator again. Okay, so n factorial common gaya upar 1 1. Now if I take r factorial common here, I will just get a 1. And if I take r factorial common from r plus 1 factorial, what will be left? R plus 1, right? Using this formula, right? Did you understand?
Yes.
Acha. And similarly, if I take this thing common, what will be left in the first term? N minus R, right?
Yeah, got it.
Okay, and now if you just add these fractions and do some cancellation and again multiply, you will, and this is equal to n plus 1 CR plus 1. You can check using the original this formula. You can put n plus 1 R plus 1 and check. So this identity you will keep in mind. Now the proof. Okay. So first base case is proof by induction first of all. Base case is for 1. So x plus a whole to the power 1 equal to how much? X plus a. What does the binomial theorem tell us? 1 c 0 x to the power 0 a to the power 1 plus 1 c 1 x to the power 1 a to the power 0. Okay, what is the value of 1 c 0? 1 factorial by 0 factorial, 1 factorial. This is 1. So this term is 1 into x to the power 0 is 1 into a. So this is simply a. 1c1 is again 1 factorial by 1 factorial, 0 factorial. This is again 1. So this term will become 1 into x to the power 1 is x, a to the power 0 is 1. So this is x. So LHS says x plus a whole to the power 1. This is simply x plus a. RHS is this horrible expression, but we simplified it and got same thing, x plus a. So LHS RHS matching, base case confirmed. You can even check for x plus a whole square. You know the formula, x square plus 2ax plus a squared. You learned this in school only. So you can just put 2c0, 2c1, 2c2. All this you can put and you can check that it is coming like this only. Then x plus a whole cube ka formula also you know. X cube plus 3a x square plus 3ax a square x plus a cube. You know, right? This also you can check using binomial theorem. And only these three formulas you learned in school till class 10. But using binomial theorem, I can even evaluate x plus a whole to the power 10 without multiplication. X plus a whole to the power 100. Anything I can do. Okay. Actually, binomial theorem, you can generalize for real numbers also. But for that, you need some calculus, and there we are only dealing with the we are like it is true, but I am not teaching you this. I am just teaching you this for natural numbers. But in general also it is true. The proof needs calculus and Taylor series and all that. Okay. So what is the step 2 of induction? Tell me.
Sir, we have to consider it true for k.
Very good. So okay. So what am I assuming basically? X plus a whole to the power k equal to k c0 x to the power how much? 0. A to the power k plus kc1 x to the power 1, a to the power k minus 1, and so on till k c k x to the power k a to the power c. This is what my formula tells me, right? Any doubt?
No, sir.
Okay. Now what do we need to prove? We have assumed it is true for k plus 1. What do we need to prove? We have assumed it for k. Assumed it for k, we need to prove it for k plus 1, na?
Yes, sir.
So what is the LHS for k plus 1? X plus a
Should the last term not be
into
k minus?
x plus.
Should the last term not be k minus 1?
No, no, no. It's correct only. It's okay only. Should I proceed? Okay, I'm continuing. So you can, using distributive property, you can write this as x into x plus a to the power k plus a into x plus a to the power k. You can write this now.
Yes, sir.
Now what you have to do, you have to x plus a this entire expression. Okay, this I am calling blue circle. Basically x into this entire expression plus a into this entire expression. You just expand the brackets and write the expression. Okay, and then you uh, use this identity. Everyone please pay attention. I am not completing the proof homework. I am giving homework again. This is the second homework. We have to use this identity. Everyone noted the identity, na?
Yes, sir.
Okay. Okay, you have to use that identity and you have to put that blue circle in the bracket and expand the bracket and write down the summation, and somehow you have to bring it for k plus 1, the RHS you have to bring. Okay, this is your homework. It is simple only, but still it is homework. So if you complete that step, basically your proof is done, because what else do you need? You have proved it for k. You have proved it for k plus 1 if k is true. Okay, so anyone has any doubts or want to note down anything?
Sir,
Okay, so now I will do my final question of today, after which we can do that. Ask me anything. Acha, will the ask me anything be recorded? It is not like maths, na, so I think you don't need to record it.
sir, what are you saying?
I'm saying that like after the maths part is done, you can ask questions, na, as so career decided. But
Yes.
like those who are not attending the class, if they see a very long lecture file, then they will not press it and they will not learn induction. So what am I saying is that as soon
Sir,
as the class stops, you just
should I
stop the
stop recording? I mean, after you have given this
not
question,
now, not now. After the last question, you will stop recording. Then we can discuss. You can record that separately also if you want a recording, but don't merge them, or else people will not click the link and they will not learn induction, which will be very bad for us. Like if the class is short, then they will tend to press the link. Nothing else. Sabyasachi, everyone does not know induction clearly. Can see. So my last question for today, which I will again not complete. You have to complete. It is again a homework. I will just say the first few steps. So the question is, you can express any such a natural number n in any base uniquely. Have you all done this question? Because I think you had a class on bases. I don't know what exactly has been done. Have you all
We
done this?
haven't done.
Okay. So like you know this thing happens, but you don't know why it happens, right? Basically, what is the statement? Suppose you have the number 5. How can you write 5? You can write 5 like this. How else can you write 5 in base 10? There is no other way to write 5, na? In base 2, how will you write 5? Someone tell me what is the base 2 representation of 5?
101.
Sir, 101 base 2.
101 base 2. Okay. So, acha, in base 3. Base 3, tell me. Hello.
Yes, sir, just a minute.
Okay. I am not calculating, so whatever you tell, I will write down. Okay. Please give correct answer.
Sir, 12 base 3. Sorry, 12 base 3.
1, 2 base 3. 1 into 5. 3 plus 2. Okay, you are correct. So, what is the claim? Like, how can 5 be written in base 3 only using 12? You cannot write it as any other thing, right? Or in base 2 only 101. Only there is a unique representation. That's why the word uniquely. In any base, if you write 5, it will only have one representation. You cannot write it in 2 ways or 6 ways or anything like that. Okay. And this any word is important because like it ensures that you can write every number. Like might be some number x which you can write in base 10, but you cannot write in base 2. Can this happen? No, it cannot happen. This is basically what the statement is saying. You can write anything you can write, and the representation will be unique. These two words are very important in this question. Okay. So how will you prove it? First of all, if n is a number in base b, I can write it a0 b to the power 0
I think
plus
repeatedly applying the division algorithm will help.
Yeah, you are correct. That is basically what I am doing. Okay, this is a0, a1, ak. Basically, if this is the number representation, then this is the, like if you multiply everything and expand, then this is basically. For example, if n equal to 1729 base 10, then it is 9 into 10 to the power 0 plus 2 into 10 to the power 1 plus 7 into 10 square plus 1 into 10 cube. So this notation 1729 and this expansion in terms of the base 10 powers of 10. These two things are equivalent. So basically this is my statement. Let us assume the number n is like this. Everyone convinced?
Yes, sir.
Okay. Now Saptasya, tell me what was your idea? Okay, first before his idea, step one is always check the base case. How will you check the base case? Like you know that it can be done in base 10, right? If it can be done in base 10, I think someone told me about backward forward induction. Who was that?
Sir, actually, I only had said, I had only read about it, not
Acha, acha.
properly.
Now it might be something like this. Now, like you know every number in base 10, right? All numbers, natural numbers in base 10, you know. So from 10 to 2, you can do one induction, and from 10 to infinity, you can do another induction basically. Maybe something like this is backward forward, I don't know. Okay, so now
Okay, I'm
what?
just telling you this in demo. Suppose you take the base case, then you show that it is possible for k, then you show that it's possible for the previous one, that's k minus 1, and then the next one, say 2k. Now that's what basically this forward backward is.
K, then K minus 1, then 2K.
Yeah, the backward one is k minus 1, and the forward one is 2k.
2K or K plus 1 also, right? That's
Yeah, you can do that as well.
Acha, acha, yeah. That is basically what I was saying, that 10 to 2 is the backward, 10 to infinity is the forward. Like this. Okay, so n equal to a0 plus a1b plus a2b square ak b to the power k. This is my number. Now I can write this as a0 plus b times a1 plus a2b uh, ak b to the power k minus 1. I just took b common, right? This is okay, na?
Yes, sir.
Okay. So now, if this thing has a unique representation, okay, if just this part has a unique representation, then I can just not this part actually. This part, if this part has a unique representation, then I can just multiply it with b. The multiplication, the product after multiplication will be unique. And then if I just add a0, that will also be unique, right? You cannot get two answers after multiplying two numbers. There is always one answer, na? And same for addition. So if I can prove that this representation is unique, then the overall thing is also unique, right?
Yes, sir.
Okay. So how will I prove this is unique? I don't actually need to prove it is unique. Now if I apply strong induction, what was strong induction? I did not assume it for the previous one. I assumed it for all the previous ones from 1 to itself, right? basically my assumption is 1, 2 till n minus 1 all have unique representations. This is my assumption, induction hypothesis. So if all of them can be written uniquely, then this number, how many digits does this number have? Someone tell me. If you write it in base B, how many digits will it have?
Sir, k minus 1.
No, k digits. The digits are A1, A2 till AK.
Okay, sir, I understand.
And how many digits will n have?
Sir, k plus 1.
Yeah, so n has k plus 1 digits. This number has k digits. So obviously this number is smaller than n, right?
Yes, sir.
So if it is smaller than n, it is inside this list, right?
Yes, sir.
Because this list is just the list of numbers smaller than n. So if it is in this list, it has a unique representation. That is our assumption, right? Understood?
Yes.
Yes, sir.
Okay, so if it has a unique representation, just multiply b, add a0. You get the unique representation for n also. Hence proved by induction. Anyone who has any doubts in the proof?
You can explain after the strong induction part.
Okay, so basically what we did in weak induction, we assumed it is true for n, then we proved it for n plus 1. This is what we did, na?
Yeah.
In strong induction, we assume it is true for 1, 2, 3, 4, everyone till n. And using this entire information, we prove it for n plus 1. Like in weak induction, we just assume the previous term is true. In strong, we assume that all of them are true. Okay.
So what did we do in the proof? Can you explain the proof?
So in this proof, I have to prove it for n, right? Let me use another color to highlight. I have to prove it for n, na? So using strong induction, I assumed it for 1, 2, 3, 4 till n minus 1. Everyone I assumed it to be true. What I assumed that from 1 to n minus 1, all natural numbers have a unique representation in base B. Got it? This is what I assumed. Okay.
Yeah.
So now if I assume this and I wrote n like this, n equal to a0 plus, if I take b comma, I get this number. Okay, I just took b common and subtracted it. Now how many digits does n have? N is a k plus 1 digit number, na? Like
Yes,
if I
yes.
write n in base b, it will be a0, a1 till ak, like this. And how many digits does this number in the bracket have?
K.
It has k digits, na?
Yeah.
See? It will be like a1 till ak. a1 b to the power 0 plus a2 b to the power 1 and so on till ak b to the power k minus 1. So it is a k digit number, right? Understood?
Yes, understood.
So if it is a k digit number, it is smaller than a k plus 1 digit number. है ना?
Yes.
So if it is smaller, then it is inside this list, because this list has all numbers smaller than n,
Yes.
right? So and what does my assumption say? My assumption says that all numbers in this list have unique representation. So this bracket thing also has a unique representation, right?
Yes.
So if this has a unique representation, I can just multiply it by b. The answer will be unique. Then I can just add a0. Again, the answer will be unique. So my
Yeah, I got it.
representation for n will also be unique. Hence true.
Yes, got it. Thank you.
Okay. Okay, so you can stop the recording.
Sir,
Huh.
sir, I have solved that binomial theorem problem.